Hello and welcome to a quick demonstration of the Aspherix Assistant, an AI skill for harnesses like Claude Code that allow you to set up Aspherix simulations using AI. We recently released our public repository on GitHub at CFD-DEM project Aspherix Assistant that provides this skill that you can locally install on your machine. It will allow Claude Code to effectively search our documentation and with some guidance, set up correct Aspherix simulations using a simple prompt. With the Claude Code skill installed, we are now going to set up a simulation using AI and Claude Code. I am in a project folder. The only file in the folder is this project markdown file that contains the specifications for the simulation. Before I start Claude Code, I am going to load the Aspherix environment so that Aspherix is available to Claude Code, and I am going to launch Claude. We should see that if I was to type skills, that the Aspherix Assistant is already enabled. So the assistant is there, and I'm going to switch Claude to auto mode so it can basically do everything by itself. And I am going to basically just tell it to read this project file and set up the simulation and run it. Claude will now read the project file. It will figure out what it needs to do. It is reading its resources, and it will now go through the entire process of looking up the documentation that it needs for the specific Aspherix commands. It will figure out which of these commands it actually needs to use in the simulation. And at the end of the day, it will have fully set up an Aspherix input script. It should also run the input script to verify that it is working. And if it finds any mistakes that it might have made, it will actually go through an iterating and debugging process to figure out what changes it needs to make so that the final simulation that it is running is actually correct. As Claude is running here, we notice a few things. One, it has access to our public documentation. And two, it also has access to our public repository of examples. Claude will alternate between looking up documentation, and if it finds itself somewhat uncertain, it will actually look for an example in our public repository and use that as a reference. Claude has reached the stage where it is actually writing the full input script. As it writes the input script, it will run the Aspherix command using the input, identify any mistakes that it might have made, correct those mistakes, and at the end of the day, it will run the simulation in completion. And with the simulation now completed, it is giving us a nice summary of the setup, essentially what work it has done, and it is now also going to give us some information about what it thinks the results are. Finally, we can ask Claude to open the results in PowerView, and it will tell PowerView to open up the Aspherix simulation PVD file. We see that the simulation has completed, and all we need to do is run the Aspherix macro on the results to extract everything. Now with the results opened in PowerView and the Aspherix macro invoked, PowerView has extracted all the results and we get to look at the simulation that Claude has set up. So we will just simply play PowerView and we will see that the particles have been inserted into the rotating drum, and after the particles have settled, the simulation itself is now running, the walls are rotating and the particles are slipping down the walls in the rotating drum simulation. We should also be able to look at the input script here, and we see the full input script that Claude has generated. It has selected the correct particle shape, it has selected a simulation domain that is slightly larger than the drum geometry, it has set neighborless coefficients, it has set materials, contact models, set the simulation time step, it has set the check time step command to make sure that time steps are small enough for the actual simulation. It has enabled gravity, it has enabled output, It generates the particle templates and the distribution. It generates the walls for the simulation using primitive walls as per the project specification, no meshes. It sets up the region for insertion. It inserts the particles. It sets up the commands for monitoring the results, sets up the output. It runs the simulation until the particles have all been inserted. It then disables the commands that need to be disabled, and it sets up the walls again, this time setting up the walls with shear components so that they are rotating, and then it runs the simulation for 3 seconds. In total, Claude has successfully set up an Aspherix simulation using nothing but a skill and a project specification file that will essentially tell it what simulation it needs to set up. Thank you very much for your attention, and we hope that this Claude skill is useful for you in setting up Aspherix discrete element method simulations.